So the good news is that part of this, most of this actually, today's unit anyways, is a lot of stuff that was talked about in Algebra 2. We kind of like dip your toe in the shallow end of rational functions in Algebra 2 and Algebra 2 honors. But then we're going to start to get, you'll see the AP twist on it when it starts to talk about limit notation and that kind of stuff. Katrina asked first, and then you can go. So we start with, like, what is a rational function? Rational functions are quotients of polynomial functions. Quotients being there's going to be a fraction here, okay? They can be expressed as f of x equals p of x over q of x, where p and q are polynomial functions, and q of x cannot equal 0. So a lot of times they'll make almost like a word problem out of just building the rational function. In the wording, it will say f of x equals p of x over q of x. P of x is this, q of x is this. And you actually just have to stack them. You have to pay attention to which goes in the top and which goes in the bottom. And then you have to stack them to know it's a rational function. The domain of rational functions is the set of all real numbers except the x values that make your denominator 0. So the very first thing that we do when you're looking at a rational function, because eventually we're going to do multi-steps, is check for, well, we'll factor it to check for domain, but then we'll check for domain, okay? Eventually, we're going to talk about we can cancel parts out and all that stuff, but you don't do domain after you cancel out. You do domain from the very beginning when we initially look at our function. So it is whatever would make my denominator 0. So example 1 says find the domain of the rational function, and we're going to write the answer in interval notation. So when we look at A, I am going to completely ignore my numerator for now. The denominator is where I'm looking for my domain restriction. I would say this cannot equal 0, so x cannot equal 4. And in interval notation, my domain would be negative infinity to 4, not including the 4, and then 4 to positive infinity. Then you go to B. Again, we're going to ignore the numerator. We're going to look directly at the denominator, and we're going to say x squared minus 36 cannot equal 0. And then you can either factor this, or you can use the even root property, but you will see eventually it's going to be important to factor it, so I'm going to take that route. X plus 6 and x minus 6, neither of them can equal 0, so x cannot equal negative 6 or positive 6. So in interval notation, it goes from negative infinity to the smaller number, which is negative 6. Union, the smaller to the bigger, negative 6 to 6. Union, the bigger to positive infinity. Good so far? Okay, so then we go, okay, how do I read it from a graph? What you will see on a graph, and this is what happened on your graphing utility, is that there are asymptotes there, you just don't see them. So if my graph is taking a hook and taking that turn, there's something stopping it there. There is a vertical asymptote and there's a horizontal asymptote. That's what's causing the curves. So when I'm doing domain, am I looking left, right, or bottom, top? Left, right. So my domain is the furthest point to the left. We're going to assume these would continue on in both directions, or there would be a dot to stop it. Rational functions will continue on like that. So what's the smallest x? Negative infinity. And then where does it stop? 0. And we put a parentheses because it cannot include that 0. There's a vertical asymptote there. Then we union. We started again at 0. And how big does it go? Positive infinity. It's going to keep pointing to the right. Good so far? All right, now let's talk about end behavior with rational functions. So end behavior for rational functions, by definition, is the same as everything else. We're describing the left-hand and right-hand sides of our graph. We're talking about the limit as x goes to negative infinity, and that's your left-hand behavior. And we're talking about the limit as x goes to positive infinity, and that's the right-hand behavior. You will also see words as the input decreases without bound, which means left-hand behavior, or the limit as it input increases without bound, which means the right-hand behavior. Now on this graph, there's again a vertical asymptote at 0 and a horizontal asymptote at 0, which means these blue curves are going to get as close to possible without actually crossing through your x-axis. And so both of these are going to stay above the x-axis, and both of those y's are going to be approaching 0. So the left and right hand behavior on a rational function is going to be based on that horizontal asymptote. So you're going to learn how to read it from a graph, and we're going to learn how to find it from using a table, and we're going to learn how to use it from the equation. So example 2 says find the end behavior of the rational function. I'm going to teach you in a minute how to do it from the equation. We're not going to look at that yet. We're going to look at this graph. So where does it appear as though there's a vertical asymptote, let's just say? Yep, like -4, there's a vertical asymptote. And then notice what's happening on the ends of this graph. They're not approaching the same horizontal line, which means there's what's called a slant asymptote here. So you notice that they're not approaching the same like y value. The other ones were both approaching 0. If there's a horizontal asymptote, they'll both approach the same y value. But this is clearly not happening. That curve is going to take this curve and it's going to keep going this direction. And the bottom left curve is going to keep on going in this direction. So let's start with the left-hand side. What's happening to those y values? As it keeps going and keeps going and keeps going, what's going to keep happening? They keep decreasing. So what's happening to the f of x? It's going to, what would be decreasing forever and ever and ever? -infinity. And then on the right-hand side, it's going to keep going in this motion. So the limit as x goes to +infinity, what's happening to those y values? They're increasing forever and ever and ever without bound, which means it's going to infinity. Yep.
Why don't you look at like the other arrow?
Because we're talking end behavior, so always the outer ends. We're gonna, those vertical asymptotes are what 1.7 and 1.8 and 1.9 is about. And it will ask you to describe the behavior graph as it's approaching the vertical asymptote. Now it's different. Now you're coming in. End behavior is always the edges. So all the way left and all the way right.
For the slide before it, why is...
Okay, so I can fill out this chart. I took my function and I plugged it into my y1, okay? We have learned that there's multiple ways of finding the output value depending on the input value. So let's talk about some of the options. If I hit graph, this is what the graph of my function looks like. So one of the things we'll talk about on this graph is notice that there's two vertical asymptotes this time, right? One at like -4 and one at 1, 2, 3, 4, like one at 6, right? And there is a horizontal asymptote there because what's happening on the ends of my graph is getting impacted by it. But what's unique about a horizontal asymptote is that it can be crossed through. So if you notice, the middle curve is crossing through my horizontal asymptote. A graph cannot cross through a vertical one because it's undefined there, but it can cross through a horizontal one. The horizontal affects the outer edges of your graph, the end behavior, not necessarily the middle, okay? So if I look at this graph, one way to find a value would be I go second, trace, value, and I type in 10. And it actually gives me a fraction. So I'm going to show you another option, but I'm going to write this in just so that I wanted you to experience this so that you could see what could happen. So 39/56. I could keep it that way, or I could eventually convert these all to decimals, what I would probably recommend. If you wanted to force them into decimal, you can do that through your menu, like you can do it through mode, but I would say I leave that alone and I'll show you a different way to do it, okay? Now, if I go second trace and I go to value and I hit 100, it says quit, go to, and it says error invalid, attempted to use a variable or function where it's not valid. If I go to, it's basically just taking me back to my graph. And what's happening here, it's not that it's undefined there. If it's undefined, it will tell you it's undefined there. What's happening is it's so far off my graph that my calculator can't find it, okay? So I could choose to zoom all the way out, but I'd have to literally adjust my X min and max to be negative 10,000 and positive 10,000 to catch it all, which is a lot of work. What's your other option? How else can I find a value? I could go to table. Sure, I could go to table. But I'd have to really go, right? What's another way to find your input, though? Or your output given an input? What'd you do with rate of change? The Y values. So I could go back to my regular menu, and I could go alpha trace Y1 and type 10. Well, I already have 10. But if I type 10, here, I'll show you this trick. Type 10, you get your fraction. To get from fraction to decimal, I go math, arrow to the second option, hit enter, and it's going to push it into decimal. So 0.696. Now I'm going to go back up. I'm just going to arrow up to Y1 of 10 and add a 0. And arrow up decimal. And I get 0.0408. And I arrow up. And I go to 1,000. And I get 0.004. And then I go arrow up, and I do 10,000, and I get 4.007 E negative 4. And what does that mean? Oh, there's actually an extra 0 in there. It means that's really 10 to the negative 4. So I'm going 1, 2, 3, 4. 1, 2, 3. So 0.0004 would be what's there. Now, technically, that rounds to 0. But it's important to understand that that is not 0, right? Because there's a horizontal asymptote at 0. So even though it's teeny tiny, it is still above 0. So I'm going to keep 0.0004 so that I remember it hasn't crossed 0. Now I do the same thing with the negative. So I'll show you another trick, and that is the insert. If I go up to 10, let's just go up here. Y10. If you want to put a negative in between, like if I arrow over and I hit the negative, it overtakes the 1. But you have an insert button, it's above your delete. If I do second insert, I can put the negative in wherever it is. And then it does that. And then I go math, decimal, and it gives me the decimal. Insert is life-changing, right? 0.427. Go up, add the 0. Oh, it's negative, sorry, negative 0.427. Negative 0.039. Arrow up, add the 0. Negative 0.0039. And 10,000. Negative 3.999 E to the negative 4. So again, 1, 2, 3, 4. Negative 0.0003, which would be 0.0004 if it rounded. We haven't really needed to use it, but when I go to use it, I'm like, oh crap, we haven't done this yet. Yeah.
So, negative 3.999, why are you putting like 4 zeros before?
Because it's E negative 4, right? E negative 4 is like that times 10 to the negative 4. So this is like your scientific notation. That really means, negative means before. So there's 4 zeros before the first thing they gave you. So I have to move not 4 zeros. You move your decimal 4 places. So 1, 2, 3, 4 means there's 3 zeros in front of it. Yeah.
Can you do that insert?
Yep, I'll come over there. Okay, so notice what's happening. Which of these charts is your left hand and which of these charts is your right hand? Is the left hand and the right hand the right hand? No, right? This says, it says it here. It says increases with outbound, so this is my right hand behavior. This says decreases with bound, this is my left hand behavior, but also these values are getting bigger, which is right hand. These values are getting smaller, which is left hand. Okay, so what's happening? Let's talk about the right hand side first. What's happening to these values? Getting bigger, getting smaller? They're getting smaller, they're getting closer and closer to what? 0. So the limit as x goes to increase, so positive infinity, g of x this time equals 0. And what's happening to the y values? Getting bigger, getting smaller? Smaller? No, bigger. They're getting bigger, right? Negative 0.4 is smaller than negative, because they're negative, right? So these are actually getting bigger and getting closer and closer to 0. So the limit as x goes to negative infinity, g of x also is going to 0. So the right-hand side was above my, if you remember what the picture looked like, the right-hand side was above your horizontal asymptote, but still approaching 0. And the left-hand side was below it, but still approaching 0. Questions so far? So a twist on this question, like, do you have to learn how to do both things? Yes, you need to learn how to use it from a graph. I'm going to teach you how to use it from an equation, but you also could just get given the table, and you'd have to understand the values of the table. They cannot give you the equation and just give you the table, and you have to look at the pattern of the values, okay? And sometimes they're vertical, and sometimes they're horizontal, and sometimes they're getting bigger, and sometimes they're getting smaller. You have to understand the relationship between the inputs and the outputs. All right, so now let's talk about how we would figure this out. How will we learn the behavior of our graph based on a chart like this? It says find the end behavior of the rational function by completing the table. So I've got my rational function, and it wants you to find these values. This is where your graphing utility comes in hand, because we have to plug that in. All right, so I'm going to bring in my fraction. Remember alpha, y1, or the little shortcut for some of you is your fraction. 4x minus 1 over x squared minus 2x minus 24. And I'm going to graph. Okay, so without seeing them, because you have to be smarter than your calculator when it comes to rational functions, you should know that there are two vertical asymptotes this time, right? Because my graph starts, then stops, then starts, then stops. Every time it starts and stops, there's a vertical asymptote. So there's two vertical asymptotes, and the end behavior is just all the way left and all the way right. So what's weird about a horizontal asymptote that throws people off is that things can actually cross through a horizontal asymptote. The middle point, there's an asymptote, there's a horizontal asymptote here at 0, but that middle graph is actually crossing through it. Because a horizontal asymptote is not that it's undefined there, it just affects the end behavior of my graph, okay? A vertical asymptote, a graph can never cross through because it is literally undefined at that vertical asymptote. But a horizontal can be crossed through, which is what's happening here, okay? But what are we looking at when we're talking about our end behavior is the left and right. So what does it look like on the left-hand side? What does it look like the y is approaching? Does it look like it's stopping at a value, or is it going to go on forever? Left, it's going to go on forever, but the y, it looks like it's going to hit that ceiling, right? It's never going to go above 0. Does that make sense? And on the right-hand side, what does it look like? It would never hit 0, so it's also approaching 0. Does that make sense? All right, so what it's asking you to do is use the value in the chart. So I'm going to go second, calc, value, and I'm going to type in 10. And I get a fraction. So I'm going to write my fraction here so that I can go back and figure this out later. 39, there's a way to reset this. I'll show you in a second, but I didn't do it yet, so I'm just going to keep going. Second, trace, value. Yeah, it would be best in decimal form, and you can switch your mode to force it into decimal form, but you can also figure it out. There's a million different ways to do this, but 100. What's it say there? It says attempted to use a variable or function where it is not valid, okay? So it means it's undefined here. Is your zoom out? I'm going to keep going and then I'll go back to it. Hang on. Second, trace, because otherwise I'll lose the video. 1,000. Okay, so now what's happening is it's not undefined. It's that my graph, that x value is so far to the left that my calculator can't see it. Does that make sense? It's so far left that it can't get that value. So it's not that it's undefined, because that will be a totally, when we get to that with holes, you'll see that'll be a totally different value, okay? So what's the other way to find what it would be if I plug something in. So I'm going to go back to the main menu. I'm going to do alpha y1, open my parentheses, and do 100. And again, it gave me a fraction. Oh, good. So I'll show you from here. Okay. The way to force a fraction to a decimal, one, I can change the settings on my calculator, but two, I can go to math, and I could literally go down to 2 that says arrow decimal. And I can enter, and it's going to give me the decimal. So 0.041 is what I would round to because it's 3 decimal places. I'm going to do the same for the 10. So y1 of 10, math, arrow decimal, 0.696. Okay. Sorry? Because it's not undefined, it's just so far off your graph it can't get it. So you can either zoom really far out, you would adjust your window, your X window would have to go to 10,000. Or you could use this method, which is the Y1, which I think is easier. Yeah. Okay, Y1, 1,000, 0.004, Y1, 10,000, and I get 4.007 e to the negative fourth. Remember, this is like saying 4.0007 times 10 to the negative fourth, which means 1, 2, 3, 4 places back. Yep.
Where can you find the decimal thing for the
Math. And then the second thing down. Yep. Still with me? Now, technically that rounds to 0, but I don't want it to be 0 because I need to know that that's not 0. That's just a little bit bigger than 0. Does that make sense? Okay. All right, now I'm going to do the other side. So same thing. I'm actually going to come up here. And I'm going to second insert, lets you put something in that spot. So I did second insert, and I'm putting, I hid my calculator. And I put in the negative. Oops. I put in 2 negatives. And I'm going to go math. Decimal. And I get negative 0.427. I'm going to go back up. Add a 0. Negative 0.039. Back up. Add a 0. Negative 0.00399. And go back up. Add another 0. And I get negative 3.9993. There's no 9. Times 10 to the negative fourth. So 1, 2, 3, 4. 1, 2, 3. So it's 0.0004 if I round it.
For the negative 1,000, why are you not rounding?
Well, just because that will round, I can round it to 0.4. It doesn't matter. What's important here is to figure out, because even sometimes they'll give you the chart and it will be rounded sometimes and sometimes it won't, right? What's important is that it's literally asking you what's happening with this behavior. So if I look at where X is 10 and 100 and 1,000 and 10,000, what part of your graph is that, the right or the left? This is the right part of my graph, right? And what's happening to those values? They're getting smaller and smaller and smaller and smaller and smaller, but we made sure to notice that this did not hit 0. So it's smaller, 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 approaching 0, never hit 0, which means the right-hand side, the limit, as x goes to positive infinity, g of x this time is going to 0. And then on the left-hand side, right, because it's negative 10, then negative 1,000, so it's getting further and further left. What's happening to those values? Are they getting bigger or smaller? Are my g of x values getting bigger or smaller? They're getting bigger. Oh, this should have had a negative. This was a negative. It was there. I lost it when I wrote it, okay? If they're getting bigger, but again, getting closer and closer to 0, never crossing 0, which means the left-hand side of my graph is also going to 0. So I'm going to teach you how to read it from your equation, but the catch comes if they don't give you an equation. There are times in which it will not give you an equation, but it will give you a filled-in chart. And if it gives you the filled-in chart, you have to be able to read that filled-in chart and understand what you're looking at. These values were decreasing. On the right-hand side, they were decreasing and decreasing and decreasing, getting close to 0, but never hitting 0. And on the left-hand side, these values were increasing, increasing, and increasing, but again, never hitting 0. Yep.
So since you said from the end behavior, how come you just did like write out the end behavior for the middle part too?
Because ends are outside.
So
Nothing in here.
So we're referring to the end behavior only time?
Only left and only right.
Okay.
Yep.
More than one point to ask.
All right, so here's the rules if I have an equation. And if you could remember your horizontal asymptotes, it's just stuff that we did in Algebra 2 Honors. If you could remember this, then anytime they give you an equation, it's like a 10-second, I could figure out the horizontal asymptote. If I can figure out the horizontal asymptote, that's my end behavior. So the line y equals b, which means it's an equation and it's a horizontal line, is the horizontal asymptote of the graph of f when the limit as x goes to negative infinity approaches b, and the limit as x approaches positive infinity is b. So in this graph, let's just say, it looks like the horizontal asymptote is at -1. So I don't care about anything happening in the middle here. I want to know what's happening all the way left, and I want to know what's happening all the way right. And they're going to be the same. If there's a horizontal asymptote, then the limit is that horizontal asymptote on both sides. So if I had a horizontal asymptote running through -1, then this limit as x goes to negative infinity, f of x equals -1. And the limit as x goes to positive infinity, f of x equals -1. Okay? So horizontal asymptote equals end behavior.
How do we know that it's not -2?
It'll either be really obvious, like this is a little too close, but it would either be marked for you or you'll learn how to figure it out from the equation. Yeah. All right, so here's the 3 scenarios with your horizontal asymptotes. First, and this is based on the highest exponent in the numerator and the highest exponent in the denominator. So in my function, it could have a bunch of different terms after, but the n is the highest exponent in the numerator, and the m is the highest exponent in the denominator. And there are 3 scenarios. The first is if n is less than m. If n is less than m, then there's a horizontal asymptote at y equals 0, which means both n behaviors would be 0. If n is equal to m, then the graph has a horizontal asymptote at y equals, I know the y gets cut off on the right-hand side, but the y equals the leading coefficient of the numerator over the leading coefficient of the denominator. So that would look something like this. Where the exponents in the top and the bottom are the same. And if that's the case, we literally just grab the numbers on the front of them. So y equals 4/7 would be the horizontal asymptote of this function. And the last one is if n is greater than m. So if the exponent in the top is bigger than the exponent in the bottom, then there is no horizontal asymptote, and we're going to talk about how you would find n behavior in that case. So n less than, it's 0, n equal, it's leading coefficients, n bigger than, no horizontal asymptote, which means we can't use this approach to find it. Okay, if the rational function has a horizontal asymptote, then the n behavior is that y value. So if my horizontal asymptote was at 3, then my n behavior on both the left and the right-hand side is 3. If there is no horizontal asymptote, then the end behavior is either infinity or negative infinity, and this is how you figure it out. You would use just the leading term in the top and the bottom. You'd simplify it by canceling out the variables. And then for the left-hand side, you're going to plug in negative infinity, and the right-hand side, you're going to plug in positive infinity. So it would look something like this. F of x equals, let's say it's negative 3x to the fourth over x to the third. Actually, yeah, I'll leave it like that. So even if there's extra terms after this, there could be several terms in each one. I'm looking at the highest ones, right? 4 is bigger than 3, which means there's no horizontal asymptote. So I grab just the leading term, negative 3x to the fourth and x to the third. Wait for it. All right. So we grab just the leading term in the top and the leading term in the bottom. Then we're going to simplify. So I can cancel out x to the third. This leaves it as negative 3x. Now for left-hand side, I'm going to take and plug in negative infinity. And for right-hand side, I'm going to take and plug in positive infinity. This is how you figure out end behavior if you don't have a horizontal asymptote. Okay, let's start with right-hand behavior. If I take infinity, for example, think this is like in theory, because obviously I can't grasp infinity, right? But if I take infinity and multiply it times negative, let me start this with positive 3 and then we'll talk about the difference. Let's just make it positive. I don't need to confuse you before we get there. You do have to understand it if it's negative, but not yet. Let's just make it positive 3. Okay, so if I take positive 3 and I multiply it times infinity, what's going to happen? What's infinity times anything that's positive?
Positive.
It's still infinity, right? It's still going to be, I could triple it, whatever, but in theory, it's always going to be infinity. If you can't grasp it, then take some big numbers. Take 100, plug it in, it's 300. Take 1,000, plug it in, it's 3,000. Take 10,000, plug it in, it's 30,000, right? What's happening to those numbers? They're increasing without bounds, so it's going to positive infinity. That means the right-hand side of this graph is going to positive infinity. Now what happens if I take negative infinity and I multiply it times 3? It's going to be negative infinity. It doesn't change that. It just keeps making it smaller and smaller and smaller. So on the left-hand side of this, it would go to negative infinity. Okay, now let's think about that negative theory. If it had started negative, if I had actually done negative, negative 3 times positive infinity and negative 3 times negative infinity, what's a negative times a negative going to do? It's going to make this side positive, and what's a negative times a positive going to do? It's going to make that side negative. Okay, so this would end up in a negative infinity, and this would end up in a positive infinity. Does that make sense? So things like if it was x squared, and so I had negative infinity squared in there, it's going to make both of them go to positive infinity. But if the abstract idea of infinity is what's throwing you, then take several numbers in that direction. You can't just do one number. But like take 100, take 2, take 1,000, whatever, and see what happens when you plug them in. And do the same with the negatives. Take negative 100, negative 1,000, see what happens with those numbers. Okay? Yeah.
Sorry.
All right, so now let's put all those together. Find the horizontal asymptotes from the equation. And then find the end behavior. So look at A. What's the highest exponent in the numerator? 1. What's the highest exponent in the denominator? 2. What's the relationship between that? Top is less than, equal to, bigger than bottom. It is less than. N is less than M, which means what's my horizontal asymptote? At 0, which means the limit as x goes to negative infinity and the limit as x goes to positive infinity are both 0. Go to B. Highest exponent in the top. 2, highest exponent in the bottom. What's the relationship? They're the same. So what do we do that time? Grab the leading coefficient. Leading coefficient in the top is 3. Leading coefficient in the bottom? 1. So horizontal asymptote is at y equals 3 over 1, which is 3. And the limit as x goes to negative infinity and the limit as x goes to positive infinity are both 3. Yeah?
See, the leading coefficient is the one from the exponent.
The one on the front of the variable with the highest exponent. Yep. So that term is called the leading term. The number is called the degree. The number on front is called the leading coefficient. Yep.
Are we doing 3x squared over 1x squared, or are we only doing 3 over
Just 3 over 1. The only time you keep the variables is if there's no horizontal asymptote. Which we've done one with 0. We've done one with leading coefficients. And then see what's true about the exponent in the top. It's 3, exponent in the bottom. 2, what's the relationship? Top is bigger. This time if top is bigger, there is no horizontal asymptote. And this is where we do extra work. We grab the leading term in the top. There's only one term this time. We grab the leading term in the bottom. We simplify. I can cross out 2 x's and I get 3x. And then for left-hand behavior, I plug in negative infinity. And for right-hand behavior, I plug in positive infinity. So 3 times negative infinity is going to be negative infinity. 3 times positive infinity, positive infinity. Oh, sorry. Good so far? Okay. If you're evaluating a limit only on one side of your graph, it will say what's the end behavior as x goes to increase, or your input values increase without bound or decrease without bound, or you only get one side of your end behavior. You follow the same rules, okay? If it has a horizontal asymptote, then that's your answer. If it doesn't have the horizontal asymptote, then you're just simplifying the fraction like we did and plugging in one side, either positive infinity or negative infinity, not necessarily both. So we look at 5, evaluate the following limit. So notice it's not asking for both sides. This would be what? Left, right, or left? Right. This would be right because x is going to positive infinity, okay? But does it matter if it has a horizontal asymptote? It doesn't matter. They're the same. It only matters if they don't have a horizontal asymptote. Does that make sense? Okay, so what's different with this one? What's different with my numerator? It's already factored out. I need to at least know what my leading term would be, right? So if I were to multiply these two together, I'd get 2x squared. That would be my leading term. Now look at your exponents. What's true about them? They're the same. So it's the leading coefficient scenario. What's the leading coefficient in the top? 2. Leading coefficient in the bottom? 1. So the limit as it goes to positive infinity is 2. Go to B, left hand or right hand? Left hand. What's true about the relationship of the exponents? Top is bigger. When top is bigger, we do the extra work. 3x squared, 3x to the third over x squared. Simplify it out. And then I only want to know left hand. So 3 times negative infinity would be negative infinity. Yep.
When we're doing end behavior of a graph, do we look at the horizontal asymptote?
Yep. Unless it doesn't have one. So like the one that we looked at today that had a slant doesn't have a horizontal. So now you're looking at the behaviors of the arrows. Yeah.
Are we expecting anything to change from negative infinity? Or
Yeah.
just sign?
So I was saying like if it was x squared and you plug in negative infinity, it goes to positive infinity. So there are times in which it changes. Yeah.
Just the sign.
But if you're just multiplying or dividing, whatever, it's going to stay that way. Yeah. Okay, last one. Now, left hand or right hand? Left hand. And leading our highest exponent on the top is the fifth. I'm going to grab that term. Bottom to the third, grab that term. This time, I can cancel out 2 or 3 of them. There's still 2 left. So what happens when I plug in negative infinity and then I square it? It's going to go to positive infinity. That's the ugliest infinity ever, but you get the point. And then this becomes infinity. Good? Okay.
What does square root?
It won't be because it's not that's not a rational function. Square roots would be irrational. Okay, so tonight's homework is a PDF and the AP Classroom. I think it's number 3. Like I literally say you can skip it for now because it talks about a hole and we haven't gotten a hole, so I don't know why AP Classroom put it where they did. But you can literally, is it 4? 4? You can skip it. I put it in the instructions on the Canvas assignment. We will come back to it after 110. So then the next 3 nights, I actually am holding all of those questions. We won't do those AP Classrooms. You'll do PDFs those nights, but you won't do AP class questions until next week. Because they are great questions, but they combine all of this stuff from 1.7 to 1.10. So to do it now is to start at I don't know why they do it, but 1.8 without getting to 1.10 is kind of silly. So, but tonight's the last AP